Hi everyone. So next we're gonna look at root tests. This is another test that you can use to determine whether the series convergent or divergent. Okay, so the definition for root test is if given a series, let's say you have a series an, L equals to limit n approach infinity, I have a square root and then I have absolute sign an to the power of the square power of n which is equals to limit n approach infinity an 1 over n. Okay, now this L here, if L is less than 1, the series is absolutely convergent, and you can say that convergent. Okay, when it's absolutely convergent, it means it's convergent. Okay, now if L is greater than 1, the series is divergent. And there's another one we have if L is equals to 1. So we can say that the test is inconclusive. So what it means that you have to do another test. Okay, you have to do another test to determine whether the series converge or diverge. So because for L equals to 1, we can say that the series may converge or may diverge. Depends on what you are getting. Okay, how you are finding the solution for this test. Okay, so what we want to do here, we want to look at some examples. So let's start with the example given in my textbook to understand whether you know how to apply this test correctly. So the first example is, let's say, this one. Okay, determine if the given series is convergent or divergent. Okay, so that's the question. Determine whether the series is convergent or divergent. And let's look at first example. For n equals to 1 to infinity, n to the power of n over 3 to the power of 1 plus 2n. Now it looks like this is when you have if you have a series in this form, usually you have n to the power of n, or the power of n is appearing many times. It's good to use root tests. Okay, it will be easier for you to use root tests. Okay, so by saying that, let's solve this by using root tests. So what we do, we say right here, by the root test, please mention the test that you're using. By the root test. Okay, so what is my an? This is my an. An equals to n to the power of n over 3 to the power of 1 plus 2n. Okay, so what we can say here, L equals to limit n approach infinity, absolute value an to the power of 1 over n. See, that's the definition for the root test. Let's look at it again. That's what I'm using. See that? So when you have a term, or a series to the power of n, like I said, is good to use root test because you can cancel out the n power here. Right? One of the n power here can be cancelled out. So simplifying this term here, what we had, obviously divide everything to the power of 1 over n. So I have n over 3, 1 plus 2n over n. Okay, or I can write it as limit n approach infinity, n over 3, 1 over n plus 2. Okay, this is 1 over n plus 2n over n is 2. Now look at the series here. Okay, we have n at the denominator, at the numerator. So when n approach infinity, you have infinity over whatever. So this term gives you infinity which is greater than 1. So we can say that by the root test, the series or the given series is divergent. Or you can say by the root test, the given series diverges. Okay, so this is example on how to use the root test. Okay, so it is very important to use root test when you have a series involving 1 to the power of n. Now, I know what you are thinking right now. So you can ask me, why I have to use root test? I can also use ratio test. If I use ratio test, do I still get the series converge or diverge? Okay, so if you use root test, your series is diverges, meaning if you use ratio test, you should also get the series diverges. Okay, so I can prove to you. So let's use check by using ratio test. Okay, so when you have ratio test, so I have, if this is my an, which is n to the power of n over 3, 1 plus 2n. Now what is an plus 1? You have n to the power of n plus 1 over 3, 1 plus 2, n plus 1. Now let's simplify this. If you don't simplify, you have a very long term. Okay, so this is 1 plus 2 here and 2n. So I have 3 plus 2n. Okay, now what you're going to do is apply the ratio test, right? So ratio test here means L equals to limit n approach infinity, absolute value an plus 1 over an. Now, I forgot to mention that since this is divergent, that's okay. But since you're using, for both tests, you have absolute value symbol here. You're using absolute value. So if you happen to get convergent for any of the tests, you will write it as absolutely convergent. Okay, but let's don't worry about it now. Let's do this. So we have limit n approach infinity, absolute. This is my an plus 1, n to the power of n plus 1 over 3, 3 to the power of 3 plus 2n. Now, divide by n here means swapping my denominator with my numerator. So 3, 1 plus 2n over n to the power of n. So I can see that the sum of the terms here cancels out. So maybe some of you, if you are struggling with understanding how this term can simplify, you can always write it, simplify it like this, okay? N to the power of n multiply n to the power of n for this term here, and then multiply with 3 to the power of 1 multiply with 3 to the power of 2n over 3 to the power of 3 multiply 3 to the power of 2n. Okay, and then you have multiply. Maybe it's better instead of using too many multiplication, right? So let's put it like this, similar with what we have written earlier on. Okay, times with n to the power of n. Now if you really don't know how the term cancels out, you can write it like this. Now it's easier for you to see. Okay, this term cancels out, this term cancels out. That leaves you with L. L equals to limit n approach infinity 3 over 27. Obviously, I can write 3 over 27 n to the n, because n to the power of 1 is n. So what happens when n approaches infinity? Well, you will have infinity. So it doesn't matter what's your number here, which gives you infinity, which is greater than 1. So the series diverges. Similar with my root test. Okay, so you can see that both ratio and root test, they should give you the same conclusion. Okay, now let's look at another example if we still have time. Okay, so example B. What about what about this? What about maybe something different? Let me just think. What example I can give? Okay, the next example will be sum n equals to 0 to infinity n over 3n plus 1 to the power of n. Okay, so like I say, it's easier to use root test because we have a power n here. Okay, so let's write it down. By the root test, we have L equals to limit n approach infinity an to the power of 1 over n. So obviously this is my an, so I have limit n approach infinity n to the power of 3n plus 1 to the power of n over 1 over n. Okay, it's easier to see that these terms cancels out, therefore you have limit n approach infinity n over 3n plus 1. Okay, now what you can do here, you can apply the divide by the highest power, right? So what I have here, I can have limit n approach infinity n over 3n over n plus 1 over n. So that will give me 1 over 3. This thing cancels out. This term approach 0. So L equals to 1 over 3. Now 1 over 3 is less than 1. So since L is less than 1, we can say that the given series is absolutely convergent. Okay, it's absolutely convergent because we have this absolute sign here. Now, if you don't have the absolute sign, you can only say that the series is convergent. Okay, that's one example by using root test. So let's look at last example by using root test. So let's say I have this term here. I'm going to show, okay, sum n equals to 0 to infinity 5n minus 3n cubed over 7n cubed plus 2. Now, I forgot to mention that if the question, like if you look at the question given earlier on, okay, what it says here, determine whether the series is convergent or divergent. But when we are using root test, we use the absolute value, right? So we say that if it's convergent, we say that it's absolutely convergent because of this absolute value here. Okay, so if the series actually asks convergent or divergent, you can avoid using the absolute value sign. So what you can do here, you can say that by the root test, so L equals to an to the power of 1 over n. See, I don't have the absolute sign here. Okay, so let's work on with that. So I have, sorry, I did mention, I need to say that this definition is not quite right. So I forgot to put the limit n approach infinity an to the power of 1 over n. So now I have limit n approach infinity an, which is 5n minus 3n cubed over 7n cubed plus 2 to the power of n. So this whole thing is my an. Now I have to power with 1 over n. So this is very easy to see that the n power term cancels out. And then what you do, you divide by the highest power, which is at the denominator, which is n cubed. So I have 5n over n cubed minus 3n cubed over n cubed over 7 to the power of n cubed over n cubed plus 2 over n cubed. So you can see that this term approaches 0. This term approaches 0. This gives me negative 3. This gives me 7. So limit n approach infinity is negative 3 over 7. I don't have the absolute sign, right? I don't have the limit as well. So this is my L. Negative 3 over 7, which is less than 1. My L is less than 1. So all I do, I can say that the series is convergent. That's it. Okay? I just want to tell you once again, if I have this absolute sign, now another way is to determine whether this is absolutely convergent, therefore automatically it's convergent. So my notation here should be like this. Absolute sign 1 over n. So now you have to apply absolute for your every term here. Okay, so I have 5n minus 3n cubed over 7n cubed plus 2 n 1 over n. Now simplify what you get here. You will get something like this. Negative 3 over 7 with an absolute sign, which is 3 over 7. Now 3 over 7 is also less than 1. So you can say that the series is absolutely convergent. Hence, convergent. Okay, so that's the difference I want to tell you. So depends on your question. If the question asks for absolutely convergent, you need to have the absolute value. So if a question just said whether convergent or divergent, you can actually omit the absolute sign. Okay, so let's do homework. Homework time. Now, homework. I want you to do this homework and submit to me the answer. So what can be the homework? So the questions, let's say like this. Okay, number 1. I can say that test the series for convergence or divergence. That's all. Okay, test the series for convergent or divergent. Now, let's look at this term here. Number 1, summation n equals to 1 to infinity 2 to the power of 2n 3 to the power of 1 minus n. And then question number 2 is summation n equals to 2 infinity negative 1 to the power of n over n ln n. Okay, you have questions here. Now I want you to use root test. Okay, root test. Now obviously you can use alternating series test for this thing, right? So, but try to use root test and show me what you get, whether it's convergent or divergent. Now I didn't mention about absolutely convergent. So if you want to determine convergent, you can also do the absolute convergent test by taking the absolute value. Okay, now if it's absolutely convergent, automatically it's convergent, guaranteed convergent. Okay class, that's all for today. See you next time. Bye.